All right, hello, welcome to the first day of e-learning on this March 30th. Hopefully all of you are staying healthy and enjoying this time off. Please bear with me while I learn some of the software that I'm using, that there may be some pauses and confusion or so to speak as I try to work through this and get to learn it better myself. So thank you for that. All right, what I want to do is start out with this molarity and dilutions worksheet that I attached to Google Classroom. And basically it's giving you the definition of molarity. Again, molarity is, the song's going in your background. Molarity need not be a cause of your confusion. Molarity, it's just moles of solute per liter of solution, excuse me. So that's why I've included the song there, because Michael does a much better job than I do. All right, so we want to start with our molarity here, and again, we're in solutions, so we want to look at different concentrations. Molarity is one of them, the big one. In my estimate, because that's what we use for our solutions in lab. There is also molarity as stated before in the book, and there's also percent concentrations that we use quite a bit also. If we're starting to get into microchemistry, then you're talking about like ppm and ppb. Those are parts per million and parts per billion. Those are also ways of measuring concentration. So our first one, like I said, I hope is intuitive. You have a solution of table salt and water. What happens to the salt concentration as the solution vaporizes? And then use words and pictures to explain your answer. So basically what you're doing is you're taking some water that's within a beaker, you're putting it on the hot plate and allowing it to vaporize into water vapor. And what's going to happen to the concentration of the salt? Exactly. All right, so it'll be more concentrated. That's because you're losing some of the water. And there's different ways that you can draw that. For example, you could draw your little beaker there. All right, and then use different colors. Here's your water molecules. Remember, a liquid takes the form of its container. So here's a little picture of that. And then we will take the salt, sodium chloride in this case, and this will be my sodium ion. I'm going to use red for that. All right, Na1 plus, and then my chloride ion, Cl1 minus. I'll use purple. 1, 2, 3, 4, 5. And I made 5 sodium ions, so it's going to be 5 chloride ions because it's a 1-to-1 ratio. 1 plus cancels the 1 minus, making it an ionic compound. So what's going to happen then is our blue is going to vaporize or evaporate out of here, and that will leave less blue. So if we have less blue, then of course we're going to have the sodium and the chloride still there. And at the end of it all, once all of your water vaporizes, that's why you have that white solid at the bottom, which is your salt. Okay, so then we move on to a solution is labeled 0.105 molar of sodium hydroxide would contain how many moles? All right, that's a gimme, so I'm not going to go into much of that. This is a pretty well laid out worksheet, So you have your moles here, your volume here for number 3. Show me your work. Always show me your work, all right? Because that's what's going to get you the credit. Remember, I said if you're going halfway through a problem and then you find that it's a mathematical error in the end there, I'm going to give you most of the credit there for making a silly mistake. So that's okay. All right, next one, you're given the mass of the substance. All right, so in this case we have 321 grams of calcium chloride. All right, we want to use molar mass or formula mass, same thing. I prefer molar mass, so I'm going to get rid of that and make my molar mass. And that will, all right, doesn't stay, but that will be my molar mass. So formula mass. Molar mass, whenever you see that, you should think of periodic table. All right, that you need the periodic table in order to do the molar mass. All right, so if you have that, grams per mole, all right, and then we want to get moles of solute. So you'll turn this into, you'll add up the calcium, and then you'll add up 2 chlorine, and then that will give you the molar mass of it, 1 mole of the substance in grams, and that will give you the moles of the solute in this case. And then just do the work to get molarity. Remember, you can use the golden triangle. Let me see if I have that. Here is the golden triangle, which you can use to remember how to get it. Now, remember we symbolized, just coming off the gas unit, moles as N. So N is our moles, and then we have our big M, molarity, and then I put the L in there intentionally. You may see it as volume also. All right, but in molarity, when we're doing molarity problems, we have to have it in liters. So we need to remember that, and the way I do is I use the L. Dilution problems, not necessarily the case, as I'll show you in a little bit. All right, so you want to remember to use that. You can use that golden triangle. All right, so now what happens is that you have various problems to work it out. All right, so these are using the molar mass of it. These are just in words using the molar mass, and then it's on the back here where you're using the dilution. All right, so you'll see here that here's your A and here's your A, so it goes with that, and we're looking for molarity of hydroiodic acid. So remember, the equation for that is M1V1 is equal to M2V2. And I will let you get that down. Now again, like I said, it doesn't have to be in liters for this. All right, you can use milliliters, because sometimes in the lab, that's all that is practical, is using milliliters. All right, so you'll complete this chart here, and then once you get done with that, you'll answer a few word problems here. I'll give you a little caveat. All right, on the last one there, how much water must be added. So you need to figure out how much water must be added in order to produce a 0.150 molar solution overall of hydrochloric acid. All right, so that's a little lowdown on how to do this. We will review it, make sure that you understand it. Again, that's another point in my intro cartoon that I gave you guys. I said that if you have any questions, please get a hold of me. And I mean that, please get a hold of me. Email is the best route. Google Classroom, I have turned on the comments, so Please don't abuse that. Use that during this time so we can communicate with each other and make sure that we're all understanding. Hopefully this is the only time I have to do this, and I will see your lovely faces tomorrow. Again, please get a hold of me